Hola guys, and what's up? Welcome back to my channel. So as you can see over here, I'm recording my video using my phone recorder, and yeah, actually I want to record my desktop screen using the software, but yeah, due to some problems it doesn't allow me to do so. But it's okay. That's wouldn't inhibit me from doing this video. So let's get started. In previous video, I think I forgot to introduce you with the different way of writing vector. So for example, if you have a vector, so vector we must have this head arrow and also have magnitude, for example 2 unit. So this is vector AB. So vector AB is written like this, or also like this, 2 unit. This is the arrow, like that. You can use any variables, A, B, C, but make sure you have this to indicate the vector. Or you can use like this, okay? And you can also represent with the single alphabet, so 2 unit, so vector A. But you must have this to indicate vector instead of scalar. And also what I want to introduce you is with the I think with the free vector. I forgot to tell you. Free vector. So what is free vector? So basically free vector is vector in space. Vector in spaces, in space, and it can not vectors in space. They can be shifted. Okay, shifted everywhere in space, of course, everywhere in space, okay, without changing their magnitudes. Okay, this is magnitudes and direction. Okay, so suppose we have some vectors like this. So this is vector A, vector like this, vector B, vector C, vector D. So actually all of these vectors I can move it or shift it everywhere in this space. I can move like this, okay? So later we will see the use of this free vector in our addition vector, like this, or like this, like this. And we can not only vector A, we can also move vector B like this, like that, everywhere. So take into consideration that the direction is not changing, and also the magnitudes as well as. And all of this vector, I can move it everywhere like this, like this. You can move it like this in space, of course. So that's pretty much it. So let's continue with our main topic, subtopic, which is the addition of vectors. So basically you guys will learn about this triangle law and also the head to tail. But for the parallelogram law, I think it is also pretty much important in physics, but in mathematics I don't think it is too much of significance, but I will discuss about it in future video, of course. So let's have a look on the triangle law. So actually triangle law and also the head to tail law can be used in the same situation, in the same problem. So supposedly we have but first of all, let me show you how to add a vector. So suppose we have vector AB is I plus 2j, vector CD is equivalent to 3i minus 10j. What is AB plus CD vector? So it is basically AB. What is AB? Just rewrite the component I and j. So plus with this, okay, 3i minus 10j, and do the algebra. So plus, oh, don't forget this, I forgot already. So you can use this curly like this or this, okay? So don't bother too much about that. So plus 3i, okay, plus minus 10j, and regroup. Remember to regroup. Oopsie, I think I already, okay, so I and this I combined, so I plus 3i is 4i, this and that minus 2j minus 10j is minus 8j, so that's it. Okay, easy, huh? So how to use triangle law and also the head to tail law. First of all, let me introduce you with the head to tail law. So head to tail law. So you know, in a vector it must have a headed arrow like this. So this is the head and this is the tail. Okay, makes sense, right? So let me padam. So this is the tail head. So the rule states that this, so for example, this is the first vector in space, and if you want to find a resultant vector, you must have a second vectors, right? So the let me introduce you the second vector. The second vector must be here. The second vector must connect its tail with the first vector with the head of the first vector. It is okay, meaning you cannot connect the first vector and the second vector like oh my god, sorry, like this. You cannot. So this is the second vector. You cannot. Salah. That's a wrong way of doing it. So instead, the second vector must be here. Second vector, and the resultant vector is being over here. So this is the resultant, but the resultant vector is quite special because it can connect the tail with the tail of the first vector and the head of the resultant vector with the head of the second vector. So, but it cannot be done by the first vector or the second vector. It only can be done with this resultant vector. Okay, so it is quite special. Okay, so that's it about the basic idea of the head to tail. So let us apply the free vector concept. So supposedly we have what? First vector in space, I name it as vector A. Let me be let's simplify our writing. So this is vector A. We have equivalent to, okay, let me don't have to assign the value first, the magnitude, so that we can, for the sake of simplicity, of course. And vector B, we have somewhere somewhere over here. Sorry, no, let me kasih, okay, somewhere over here. So how can we find the resultant vector? So the resultant vector is simply, okay, since this is a free vector, so we can shift it everywhere we want. So I want to shift it over here. Let me have any more space over here, and this also I can shift this guy here. Okay, remember, you must always connect the first vector, this is the first vector, and the second vector by this head to tail rule. So this is the head, connect with the tail, and amazingly the resultant vector is from the first vector from the tail of the first vector along the head of the second vector. So this is the resultant vector. Okay, easy, huh? So let's see the application. I think let's see the question for you guys to have the intuition of it. Let me Okay, this is the question. So given that vector u equivalent to, so this is in a matrix form. Okay, this is in the matrix form, and vector v is this. Find the value of, so you can see over here, this is the modulus, so it means magnitude. Okay, so let us find first. This is the second question. Okay, oh my god, apa ni saya padam, saya X je lah kan. Let me cut it first. Okay, so the question wants us to find 2u minus v. Okay, meaning this u times with 2 times minus 1, check this vector in a matrix form, minus, because this is minus, v is what, 3 minus 4. So times, using the matrix law, so this is minus 2, 8 minus 3 minus 4. So we do the subtraction using the matrix law also. So we can do like this: minus 2 minus 3, okay, minus 8, 8 minus 4, equivalent to, so minus 2 minus 3 is minus 5, 8 minus 4, which is plus, is at plus 4, right? 12. So 12, sorry. So if the question asks us to find 2u vector plus v minus, right, supposedly minus, right? So this is minus. Okay, okay, so this is the answer. But okay, the question wants the magnitude of it. You can also represent this in this form, in this general form, as you have learned. So magnitude is what? So magnitude, oopsie, so this is v, is equivalent to theorem Pythagoras, right? So you just square the x component plus y component and then square, like using the theorem Pythagoras as usual. So this is 25 plus 144. So this is what? 5 plus 4 is 9. 7. Betul kah? So you can find the value. So you can find the value of 176. Oh, 69. 169. Sorry, 169 is 169 is 13. Plus minus 13, right, supposedly, but this is magnitude, so we just ignore this minus, so minus 13 units. Okay, so 169 is 169 is 13, right, if I'm not mistaken, 13. So next question, so let me padam dulu nih. So this is a quite interesting question. So diagram 6 shows a parallelogram ABCD. So even though this is parallelogram, we can apply our basic knowledge. So parallelogram, this is so these have a vector DC, vector A, B. They are parallel, and so like this. Okay. So I'm not assigning any direction, but I can actually freely assign vector AD to be there, or vector, so this is vector AD, the arrow is like that, or vector, what you want to call, vector DA, like this. Okay, so I can freely assign any direction of the vector I want, because you know, alahai, macam mana mau padam ni. Okay, padam, cut, Okay, let's so this is parallel. Okay, point E lies on the AB such that AE ratio EB is 2 to 1. So this is 2 to 1, given that EB is 4, so this is 4U, and AD is AD, which is 3V. So since AD is parallel to BC, meaning if this is a vector in space, we can shift this vector to here, meaning this vector and these vectors are identical. So using the concept of free vector, this is 3V, 3 vector V also. Okay, I think it's clear. Expressed in terms of U N or V AE. So this is easy. I think this is easy. Let me change color. So AE, okay, let me padam dulu, clear everything. So I have erased the parallel sign. I hope you can see previously. So AE, what is AE? So AE is these things we want to find. AE meaning A to E, meaning the arrow is like that, right? Okay, so since we know EB meaning E to B is like this, so they are same direction, they are collinear instead. So we make our statement if EB equivalent to 4U, since it is associated with one ratio out of AB, meaning AE is equivalent to 2 times 4U. So this is one ratio, I mean this is the one ratio, so or ratio 1. Okay, 4 times 2 is 8 U vector U, like that. Okay, because this is associated with the just one part of out of the whole thing, the whole AB, vector AB, and this is associated with 2 out of 3 or out of AB. AB is the whole thing, which is 3, because 2 times 1 is 2 plus 1 is 3, like that. Okay, so ET, let me erase first. ET, okay. So you already know the answer. So this is basically 8. So ET, where is ET? Okay, let me erase first. ET is basically this ET. Okay, since we want to find ET, so we need to use our head to tail ET. So this is the basically the resultant. So this is AE. Okay, so as you can see, the resultant here is 80, because tail with tail, head with head, so this is resultant. So 80 is resultant, so I write here 80 is the resultant vector. So we know AE is at U, and we want to find this ET. Okay, so first of all, we need to find what is R, or what is vector AT. So you realize this this symbol, meaning it has the same ratio. So meaning T is the what we call the midpoint of the AC. So the first thing inside my mind is to find the vector AC first, right? And then we divide 2 to find vector AT alone. So vector AC is equivalent to, so you travel from A to C is the same thing you travel from A to B and then from B to C using the head to tail arrow rule. So A to B basically at U plus 4U, which is 12U, plus, because this is the addition of vector, B to C. B to C is given by 3 vector V, like that. So this is A to C, but we want to find AT since this length or this length and this length having a same ratio, so we can divide by 2 only. So 12 divided by 2 is 6U plus 3 divided by 2 is 3/2V, like that. So this is 80. Okay, so we know that, okay, like that. So 80, which is the resultant vector, is when you want to travel from A to T, you can travel from A to E first and then E to T. So A to E first, then plus E to T. We want to find E to T, so make E to T as the subject, E to T as a subject. So we have what? 80 minus AE, vector AE. Sorry if I'm previously I do not mention the vectors term, but I think you can understand also. So 80 minus AE, right? So ET is 80, which is this 6 vector U plus 3/2 vector V minus what inside is AE. AE is this. You can see this AE. This is AE, AE, which is at U, at vector U, at vector U, and we just do the algebra. 6U minus, okay, do the following, this and this operate. 6U minus 8U is negative 2U vector U plus 3/2 vector V. This is the answer. Okay, so I can check the answer over here. Okay, so okay, betul kah my answer? Negative 2U 3/2. Okay, betul. So actually this is SPM 2019, last year. Actually you can access this blog. Okay, this is the link you can access. You can just type the keyword like mathematic tambahan soalan vector, and you will have access of these questions, and you can try the question without looking the answer.